All right, we are going to start with gas laws. And I want to start by talking about the things that we can measure about gases. Okay, now, first of all, it's fairly simple. If we put the gas in a closed container, we can measure the volume, which you're going to represent with a V. Okay, we also have talked about temperature. Now, remember, according to kinetic theory, temperature is a measure of the average kinetic energy of the particles of matter. So we can measure temperature. All we need is a thermometer. You might pronounce it differently. You might call it a thermometer, but we can use a thermometer and measure the temperature. But there's also something called pressure, and we need to understand that a gas exerts pressure. Now, to understand pressure, the first example I'm going to give you is imagine having a book and a thumbtack on top of the book. Okay, here it's really simple. Here's the thumbtack. The book is spread out on the weight of the book is spread out on your hand. Now, if you were to put that thumbtack on the bottom and the weight of the book was on just the little part of the thumbtack, it would poke into your hand, right? That's because even though the weight didn't change, even though the force of gravity didn't change, the total pressure did because it was gathered in a much smaller area. So pressure is equal to force over area. Now, how does this apply to a gas? Okay, how does a gas apply force? Well, we have to remember that gases are made of tiny particles, and those tiny particles are flying all over the place. Imagine a super ball bouncing around at 100 miles an hour. Or to really represent a gas, imagine 100 super balls bouncing around at 100 miles an hour. That's kind of the idea. And as they run into the walls of the container, they produce a force. The more molecules you have, the greater the force is going to be. So we can measure pressure as force over area. Now, how are we going to measure this pressure? Well, that's fairly simple. We're going to take a simple YouTube lesson here. And I know you're thinking, YouTube, okay, so we're going to look at a video. Well, not really. We're going to go back to the old-fashioned YouTube. And I will tell you, I had my kind way before you had yours. Okay. So we have a tube that's in the shape of a U. And if I fill it with a liquid, then if it's open to the atmosphere on both sides, it's going to go and fill both sides to the same level because it's open to the atmosphere. If I close one end of it and I increase the pressure on it, it's going to force this liquid down and this liquid up. If I know the force of the liquid in the area that it exerts, I can determine the pressure difference between those two. Okay. Now, if I set that pressure to where this is a completely closed end here, to where I have the tube coming up and there is a closed end to it, and I put something like mercury in it, okay, or I can even set it into a pool of mercury. Again, you already know I'm not a very good artist, okay, but I have a pool of mercury here. Okay. And this mercury pushes up. The difference between the level of mercury exposed to the atmosphere and if I have a vacuum in here, this height difference tells me the pressure. The height difference, actually, I need to know the area and the mass of the liquid. Although if I have a greater area, in other words, a longer tube, I will just have more liquid. So this height tells me about the pressure. And we usually measure this height in millimeters of mercury, okay? So millimeters of mercury is a pretty simple way to measure the pressure. At sea level, at about a normal day, that measurement is about 760 millimeters of mercury. Okay, 760 millimeters of mercury is a pretty simple measurement to remember, but we can also say a few other things. This is equal to 1 atmosphere. Okay. Now, when you go out and you measure the pressure in your tires, you probably don't measure it in atmospheres or millimeters of mercury. You're going to measure it in PSI, pounds per square inch. Now, this is equal to about 14.7 PSI. Now, all of this, and I haven't even taken into account the SI units. The SI units for pressure are force is a Newton. Area is a square meter. So a Newton per square meter is equal to the unit of force. This is known as a Pascal. So 1 Pascal is 1 Newton per meter squared. Now a Newton isn't very much weight to be spread out over an entire meter. So this is a measurement that we don't use very often. We're usually going to use kilopascals. And I know you think that's not very nice, poor Pascal. But you know, he's already dead. He's been dead quite a while. So kilopascal is our unit of pressure. And if I want to equate this, 101.325 kilopascals is equal to 1 atmosphere. Now, there are other units of pressure. Your book talks about bars, but you guys are too young to be going into bars, so we won't use bars very much in our examples. But again, as long as I know the equivalents, I can convert from one unit to another. So let's say I look at the pressure. I look at my barometer on the wall, and I see that it is 747.2 millimeters of mercury. And I want to convert that to, let's say, PSI. Well, I know these are all equal to each other. I can write a conversion factor. I'll put my millimeters of mercury on the bottom, 14.7 PSI. I pull out my handy dandy calculatorial device and I punch the buttons in here. 747.2 divided by 760 times 14.7. Very simply, I get, helps if I do it correct. When you miss a button and you put, instead of 747, you put 77.2, it doesn't come out right. But you should be able to recognize when it doesn't come out to be the right answer. All right. So in this case, we end up with 14.5 pounds per square inch. So I can convert from any one unit of pressure to another. And these are the things that we can measure about gases. Now we also need to understand that we can measure the amount of a gas. And the amount of a gas can be measured in a couple ways. The easiest way is to weigh the completely and totally empty container. And I know you're thinking, how do you get a container completely empty if it's got gas in it? Well, you can use a vacuum. And I know that idea sucks, but you can do it. You can actually remove all of the gas from a container, weigh it, add the gas to it. And then knowing the composition of it, we can convert it to moles. So the number of particles is another thing that we're going to measure about a gas. And we're going to refer to that number of particles as N, moles of gas. And these are the things we can measure about gases. The next video is going to cover some of the actual gas laws.